Welcome, welcome. Thank you for joining us. I'm Ashley, they, them, and I'll be the NAGT support person for today. So if you have any technical questions, go ahead and send me a message and I'll try to help you. And I'm really excited to get into today's webinar. First, I want to tell you a little bit about the NAGT webinar series in case any of you are new or unfamiliar. So our webinar series is a one-stop shop for increasing our community's capacity in Earth education. Our webinars feature novel and innovative work, such as Earth education research and pedagogy, new teaching materials, and the classroom and professional experiences of people just like you. The NAGT webinar series is free and open to the public. We often get questions about whether it's okay to invite your colleagues. Please do. We'd love to have them. The more the merrier. And throughout the webinar, please use the chat box as a place for discussion, questions, and comments. Additionally, feel free to use the reactions tab. Otherwise, in terms of interacting with each other in this shared cyberspace, please remember that we do follow the NAGT Code of Conduct, which expects and endorses a professional and respectful atmosphere and values diversity in creating an inclusive, supportive, and collaborative environment. I'll drop the Code of Conduct in the chat for you to review as you have the time. But otherwise, we're ready to go ahead and get started with our webinar today, which is Math for Earth Science Majors. And I'll hand it over to Eric, Rory, and Beth.
Thanks everyone for joining us today. We're excited to share some of the resources that have been developed by the Math Your Earth Science Majors Need project, where we're aiming to help build confidence, skills, and success in the quantitative skills in the earth sciences. The webinar, the overview quickly of what we're planning to cover today. We'll have some quick introductions. We'll go over a bit of the background of the project and what the modules include. Evidence for their effectiveness and recommendations for how you would go about integrating these math and statistics modules into your majors level courses. There'll be some time to explore a couple of the modules and then some time for discussion and questions. So who are we? I'm Beth Pratt-Situla with EarthScope Consortium, and along with Eric Baer from Highline College and Rory McFadden from Carleton College in CERC, we're the three PIs on this award. There have been 23 authors who were the ones who actually wrote the modules that we'll be presenting about, and our program project evaluator, Michael Coe, has been an integral part of the team. This is an NSF Department of Undergraduate Education funded project. Before we get into the webinar itself, we just wanted to make sure that we know a little more about the group as a whole. So we're inviting people to answer this poll question. So if you could launch it, Ashley, please, just so that we know the different subdisciplines that are in the room. And then also in the chat, if you have strategies you use for supporting students' quantitative skill development in geoscience courses, maybe just jot a little bit there. So I'll stop talking for a moment while people have a chance to write. Awesome. I appreciate the people are putting in answers. Give it another 30 seconds or so. Most of the participants, most of you have answered about your subdisciplines so far. A few great ideas in the chat. right, I'm going to go ahead and end the poll and share the results. And we'll talk about the chat a little bit. So fun thing here is that we're seeing quite a broad array of different subdisciplines represented. And this project really is trying to speak to the variety of disciplines here by having math examples in a broad range of subdisciplines. So I think maybe environmental science and earth system climate science are the highest, but significant number of other people, other disciplines from volcanology, tectonics, geomorph, geohazards, geochemistry, we're seeing a broad array there. Thanks to the folks that have been sharing ideas, integrate math into every class with real data, incorporating real data, experiments and analysis of data. So that's great math modeling with spreadsheets and simulations. Somebody else is talking about starting with the basic math and graphing information. So lots of ideas that people are sharing, and it sounds like a lot of people are supporting each other, so other people are agreeing with each other as far as what's being shared in the chat. I can say that I've been the project manager of a collection on the CERC called the Geodesy. Well, it's first Geodesy, now Geophysics Tools for Societal Issues, where we're like, data, we're gonna get people working with data, it's gonna be great, and it is great. But then we continue to hear hey, like my students actually still can't do the math that they need to do this awesome data. And so that's really where a lot of the motivation to be part of this project has come in. So next slide, please, Rory. But we want to let you know where this is all coming from originally. And it really started, I think, over 15 years ago with the intro level, the Math You Need project, which was run by Jen Wenner and Eric Baer. That made 8 modules related to the skills seen the most often in intro level courses. These are co-curricular modules, which means they're not done in class generally, but are alongside class and then used to support using the skills, hopefully at a higher level in other courses. This had a lot of success in leveling the playing field, we could say, and increasing student confidence. So students that started with less math skills came up closer to the level that the students that started higher with, but everybody did improve. So that was the basis for the intro level. Next slide, please. And ever since they did that project, they heard me say things like, how about majors level? Because like we really still need that. And so finally, a few years ago, responding to continued community requests, EarthScope, which runs the geophysics facility for the National Science Foundation, help working with Rory and Eric and input from Jen and moved for and other community members with initiating a majors level version for this. Since the project started in 2023, we've had 2 development workshops, and again, another one in 2024. The authors are faculty from a range of institution types like yourself, a range of subdisciplines like yourself. The topics that were selected for these co-curricular modules were selected through a multi-step community input process of surveys and what the authors put into their proposals when they applied to be an author, so that we tried to make sure it's really what the community was wanting. The testing started in the previous academic year and will wind up testing the second year of module development this current, well, I guess next month really. So all of the authors have tested their own modules and at least one other module. In many cases, they've tested multiple other modules. So that's sort of how we got to the current group of modules, which are, next slide. We have 8 math topics that range from exponential equations, log plots, ternary diagrams, vectors, things like that, things that come up in geoscience, and core statistics topics from introductory statistics, uncertainty, histograms, regression, probability. So this is the collection of skills that were really selected by geoscience and environmental science users. So what do they entail? Like, why are they different than Khan Academy? And what we're really trying to get at in this is addressing the issue, like my students have taken not just algebra, which is mostly what I'm asking them to do, but also calculus, and they still can't create a graph in my geoscience class because all of these equations in a math class do not transfer to them knowing what that should look like when they're trying to deal with sedimentary layer thickness, statistics or something like that. So we're really trying to give the students the chance to see the quantitative skills in the context of how we use it, really how they're used in geoscience and environmental science. Next slide. The core guiding principles that are based on evidence-based practices in quantitative skill development that the modules all uh, needed to fulfill, where they needed to be appropriate for majors level earth science. They should be student-centered, that is, to design to support independent, self-paced, just-in-time student learning. So the students could do them as a homework at their own pace outside of class, but then be ready to apply those skills or start to apply those skills in the context of a geoscience class. Promote the transfer, as I mentioned in the last slide, of these mathematical concepts into a variety of these earth science subdisciplinary examples. We aim to do multiple representations of the mathematical concepts. So in the course of a module, there should be algebraic, there should be images, there should be tables, words, really trying to bring it across in multiple modes. And where appropriate, use of technology such as Excel sheets or calculators, so that they're practicing how they would use it in real geoscience courses. Each module has 4 parts, and so to quickly overview what that includes: introduction for students. So the first page is how the skill is used in geoscience, why it's important, steps for solving the problems. The next page, which is really the meat of it in a lot of ways, is guided practice problems. So what would probability look like in sedimentology? What would it look like in hurricane prediction, landslides, and things like that? There is a quiz or assessment, which Eric will talk more about a little later in the webinar. So this is in a system called WAMAP, which is quite flexible and powerful in how it lets you set up math problems. And finally, there is an instructor-facing page with learning goals and tips on challenges and also an explanation of what we aren't able to cover in a relatively short module and why. So passing it along.
Thanks, Beth. Hi, everybody. I'm Roy McFadden. I'm going to talk a little bit about the effectiveness of the modules to this point. And all the data I'm going to discuss is from the 23-24 academic year. We're also testing modules this year, but that data is, for the fall is mostly done, but we're still in a preliminary analysis stage, and we'll bring in the spring data after that. So in that first year, of the module authors, we had 13 different faculty test these materials in 17 different implementations. So some instructors taught them in more than one course, and that's over 270 students use these modules throughout the academic year. What you see at the bottom of the page here, this graphic, is the way we structured the testing process. So every student would do a pre-test. That was a set of attitudinal questions, a couple demographic questions, and then math questions relevant to the modules that they were going to learn and work on in the course. And then at the end of the semester, or after they used all the modules, there'd be a post-test that was quite similar to the pre-test questions and still had the attitudinal questions. And then throughout the term, when the tester wanted to use the material or the module, the student would take a post-module quiz after assigning, reviewing the module and things like that. And all that testing was done through WAMAP. later in the presentation, we'll talk about how we think that that process could continue for people that are interested in using these modules. The first thing that's worth talking about is how did the students do after working on the modules? And these two graphs lay out their scores on pre and post tests. And I think the first thing I want to show is that on the vertical axis are the scores from 0 to 100% for this first graph on the left. The dark blue are the pre-test scores, and the light blue are the post-test scores. And one thing that I hope you notice right away is that students who start with a lower score, so this below mean group, gain more, in terms of raw score than the students that start above the mean, but all of the students improve. And importantly, if you look at the graph on the right, the improvement when we look at a normalized gain, which means that we are looking at how much they improve relative to how much space there is to get to 100%, we see that the below and above mean groups actually both do, quite similar in their improvement. So again, the graph on the left is below mean, above mean group, and then all of the students together, so you can see what their range of scores look like. And the scores go up by, on the order of 30% and on the order of 8 to 10% for the higher group. Importantly, these are on pre and post tests, but what is the impact and how the students think about how they're doing in math, or how they think about their self-efficacy toward math? And so we asked attitudinal questions that was a set of 18 items that were specific tasks that the students might do in a course, like solve a simultaneous equation, or calculate a standard deviation, or determine a linear regression line, and took those 18 items and made a scale from 0 to 10. So the students would rate how they would go from not at all confident, so a 0, to extremely confident to a 10 at doing that skill. And then we calculated a mean for each student. And these are the distributions of those students' scores on the pre-test on the left with a mean of 5.7, and on the post-test on the right with a mean of 6.6. So we see a significant improvement in their math self-efficacy using these attitudinal questions. And math self-efficacy is something that people have looked at in the past, and there's a effective domain work in the Geosciences by Jen Wenner, Molly Jamieson, and Julie Sexton that also looked at math self-efficacy. And what people often see is that self-efficacy helps predict performance or academic performance. So these are usually closely linked when they're tied to specific tasks. So I think this is a pretty important result. Then we also want to think about is what did the students think about these when they were doing? So this is the first set of modules that we looked at. The left graph is showing how the Likert scale of what students thought the difficulty level was. And what you might see is that all the blue ones are more math-oriented skills, and the green are more statistics-oriented skills. And there's a range of difficulty. Students found the vectors and exponential equations difficult, and they found the intro stats and the scientific notation less difficult. But importantly here is when you look at the helpfulness, so the rightmost graph, all of the modules, regardless of difficulty level, the students found to be helpful. They either agreed with that statement or strongly agreed with that statement. So I think that's important to see that this is something that the students were looking at and thinking it helped them in their courses. And we also surveyed them and got some qualitative information. So just to summarize a couple of these quotes from students, great introduction to ternary diagrams. A second one here is help me understand real life situations for scientific notation. And a third that I think is useful is this module was a good refresher. Students have seen many of these math skills before, but they need that support and practice with them. And for the faculty, things like we didn't have to go back to the basics. because we'd already done them, or focusing on earth science problems, help students think across the discipline. And then third, we did more data analysis in this course than previous semesters, and I was able to focus on interpretation of the results. We know those are things you want to do in your course, and we think these modules, or the authors and testers, show that these seem to be helping with that. Okay, I'm going to pass it over to Eric.
So in observing various instructors' implementations of the Math You Need modules, both in this and the introductory project, we've noticed a few things that seem to correlate with more successful use of the modules. And first of all, that the modules should really be fully integrated into the course. They shouldn't just be sort of plastered on or mentioned and said, just go do this. Really explain why you're doing it and use the modules. They should be worth at least some credit, although it doesn't have to be very much, but it really helps. And if another thing that we noticed is if you then use these quantitative skills immediately after assigning the modules, for instance, in some sort of a lab or other significant activity, so that the students can easily connect why they are learning the quantitative skill, it's a lot better. Also, something really we have found important is what's called distributive practice, where you come back to that skill again. So if you can have them not just go through the module and learn how to do a correlation coefficient once and use it, but then come back to it later in the term, that it tends to help. We've found that it's just better if students really get into it more times. And also that they then perceive those quantitative skills as something not just that they have to learn for the moment, but that they will use over and over again. So a lot of folks assign these as homework. So typically at the beginning of the assign these as homework. And then one other thing is that a lot of faculty found it was really helpful to do something to make sure that the students went through the practice problems before attempting the quiz. A lot of times students really like to go for that quiz first, and then when they can't do something, go back. And ways that some of our faculty have learned how to do this is by working through the questions or maybe assigning some of those as a turned in homework assignment. So again, this doesn't need to be super time consuming, but the modules are not just a pill that can be simply taken outside class and never referred to again. So what this looks like in practice is in a typical given term, the instructor sets expectations, talks about why they're doing it, then they assign the modules, the students do that, then they do some follow-up and then apply that in some sort of a concrete assignment, usually a lab or something like that, where they're really using these quantitative skills. So we can go on to the next one. So typically what this looks like, and Rory introduced this before, is at the beginning of the term, our implementers did a pretest. This assesses where their students were on the quantitative skills they were planning on using in the course. They would then assign the modules throughout the course. Each one of those modules had a quiz associated with it that focuses on just one of the skills. Typically, our implementers, our faculty tended to use anywhere between 2 and I think 10 or 12 of the modules. And then at the end of the term, they would give a post-test, which was very similar to the pre-test, not exactly the same, but covering the same, but equivalent. And that is how we got the kind of data that Rory just presented before. So I want to mention how these assessments are done because it's an important piece of this. And Rory, you can go on to the next one. WAMAP is an online learning management system. It is open source. It is free. And we have developed a question bank for each and every module that we have. So these are questions that are not just about, say, linear regression, but actually using linear regression in various geologic contexts or geoscience contexts. It's not just geologic, it includes climate and oceans and many other areas. So students really see how it's applied, not just like they would see sometimes in a math class. So we do have those question banks for each module. They can be integrated in Canvas if you happen to use Canvas, but you can also use it as a standalone. And that we have templates for pretest, the quizzes, and post-test. One other really great thing, oh, by the way, if you want to use this or want to try it out, you can send me an email and I'll set you up with an account, or and you can see how it works. And then the other thing that I wanted to show you is why we like this so much, which is that it really allows us to do things that normally you can't do with a learning management system. So for instance, you have it's tailored to math skills. You can create questions that have random variables within a certain bounds. And so a student can try over and over again. They don't get the exact same question. They get different numbers each time. And so that they can go ahead and try to get that mastery down, even if it takes them doing it many times. It also has the ability to do things that just I've never seen any other one do. So for instance, on the right-hand side, this is a ternary diagram where students get a percentages and they actually have to plot where on the ternary diagram that is. And each time they can try this multiple times. It gives them different percentages each time, and it will automatically grade whether or not they've got that spot. They've put it in the right spot. So it does some pretty neat stuff. And anyway, so again, if you are interested, you can, in trying it out, you can send me an email at ebear@highline.edu. And now I'm going to turn it over to Rory.
Okay, so the next thing we want to do is we want to have some time where you all can actually look at the modules and discuss them in small groups. So in a minute, we're going to start a breakout session. And Eric is just put links into 2 of the modules that we want you to look at. We're going to be in small groups of 4, and you either should look at the ternary diagram module or the intro stats module. I'm going to go to the ternary one for a second here, just to remind you that in these modules, there's 3 pages that you're going to see. The landing page, which is the overview of the math skill, that gives an intro, some example, some about how things work within those, and then have 1 or 2 example problems with detailed steps. The practice problem page is then showing, how to solve these problems for students. Importantly, it gives an example and they could solve it. And then the show hide box includes the solution after they work on the problem. And then the 3rd page, again, is the one that's more faculty facing or instructor facing, that has the learning objectives and why this module might be important, but also why it might be challenging. Okay, so I'm going to come back here and great. And we're on this page. So we're going to take 15 minutes. So we'll bring everybody back at 45 past the hour. For me, that's 3:45. And you're going to first look at the module on your own in your breakout group, and then spend about 10 minutes talking about these questions. What did you notice? How could this help you address challenges with students? Which courses might this fit in? And then talk at the last minute or so about whether or not you want to report out. We'd love to have a few people talk about their discussions. Right, could the questions go in the chat too, so those will be easy for people to see. Okay. Ashley, could you open the... All right, hi everybody. Hopefully that was useful to see a couple of the modules and talk about things that seem valuable to you, might work, or places give you some ideas. We have a couple questions in the chat already. If people want to use the chat to ask questions, that's great. We can also open it up so you can raise your hand and we'll call on you and then you can ask your question. And we'll start with Carol. Jump on in.
Can you hear me?
Yes.
Okay. Well, it took us about 5 minutes to figure out actually how to get to the module. We thought we were going to be assigned a module. So anyway, we found it in the chat. So we did the ternary one. And my first comment is that it was great to see various levels of a ternary problem. So you could give a student an easy one first. So I noticed the waves only had, like 3 possibilities or something. Whereas most of us that deal with minerals, or soils, those get pretty complicated. So that was it. The other funny thing, and that's why I'm offering to talk, is that I actually do what I call food geology. And your chocolate diagram is perfect to add into my class because they get Jello and I work at it. There's layers of Jellos, and I use fruit cocktail for fossil assemblages, for sedimentary rocks, and then for metamorphic rocks, I use grilled cheese sandwiches. I use a half a grapefruit to show dome structure. So anyway, you've added to my food geology class.
That is awesome. And one of the authors on that module, Kelly Durling, is here too. I can see she's smiling. So that's great. That's great. That class sounds fun. I might need to go.
Well, I try to make it fun because I'm teaching in community college, and I have everything from very smart high school students that are allowed to come over to class to 85-year-olds. So the math range is very, very large.
Great. Thank you, Carol. I see a question in the chat that I just want to mention. Eric responded to this, but Masa asked how we can get the modules. All of the modules that have been made by the module authors are freely available on the circ.carleton.edu website for the project. So it's in the chat right now. You also, if you go to the webinar webpage, you can get directly to those modules. Those are available. If you're interested in using WAMAP or looking at it from a instructor perspective, the best thing to do is email Eric Bear. If anybody wants to spam him, and but honestly, that way you can see what some of the questions look like in the WAMAP system, which I think is valuable to making a decision about these. Okay, other questions for the live part? And if not, I see a few more in the chat that we could jump to. Yeah, Alberto.
So I'm sorry, I just recently heard about this, so this may be obvious question, but for this set of so what they're all available online, right? The modules, but do you have like a version for the instructor, or it's just the modules themselves? It's just a one set of modules, and then you just use it.
Yeah, this is if you've looked at other things on Teach the Earth or hosted on CERC hosted web pages, you'll see other things that are really faculty facing, and you might download an activity or PowerPoint slides and then do things with students and activities. These modules are really student facing. So the suggestion is that you send students to these pages, especially the first and second page. They get introduced to the module, they practice, and then WAMAP or some other place that you make some questions is where you would have control over exactly what the quiz questions look like. And as an instructor, you would obviously see the solutions and the code for the WAMAP stuff if you used it. And the students would only get the questions. So yeah, these are a little different. They're student facing. The instructor page is the one where we talk about stuff only an instructor would be interested in. The learning objectives, the challenges, what other materials you might use this topic in. You know, if you do intro stats or linear regression, is there a more complicated assignment that might make sense to use next? So yeah, there's no like extra pages for faculty
Okay.
on the open web pages.
Okay. Self-contained.
Yes,
Right.
yes.
Great. Got it. Thank you.
Yep. We probably have time for another question. I see Joyce said something in here about don't see anything related to heat maps. That could be pretty intuitive. Okay, that's a good suggestion. In this project, we're not going to make more modules, but there's always that possibility in the future. Okay, from Rennie, I'm interested to hear from the authors on how did you address attitudinal issues while introducing, say, statistics? Did you change it post-module? Beth
Kyle or
or Eric,
Kelly?
I could answer this, but I've been talking a lot. Either you want to jump in or?
I think we've got a bunch of module authors here. So let's let them.
Sure. Anybody want to jump in on this that created these? Sonia, I see you
Sure.
unmuted. Jump on in.
Yeah, I can say when I first told my students about it, I could tell there was kind of a lot of eye rolling. Oh, some online module to do math, whatever. But as they started doing it, their attitudes definitely improved. And I think they appreciated having the geology focused practice problems. It's something they hadn't had before, other than maybe in the lab manual that we would use in class. But it was, yeah, I used it kind of for an upper division class where they should have already had the lower division problems, but not everybody had taken stats. Anyway, they came back saying that it was way more useful and better than they expected it to be. So yeah, I did see an improvement in attitude.
Thanks, Sonia. John, we'll go to you, and this will probably be the last question, and we'll have to wrap up.
Yeah, I'm just curious if I have a class and I'm not going to have that much contact time. If I could assign students to review the ones that feel a little bit behind on math and those that feel a little bit ahead on math, to pair them up to work with these tools, if there's been any experience in just having the students hack their way through this on their own.
Excellent question. Thank you. And I think one thing that is important there, that regardless of where the student was starting, you were planning to have them all do the module. That is really important. And pairing them up with experience and less experience, that's a good idea. I don't think we have an example of that an implementer specifically did that. But yes, many of the testers, authors, assigned these asynchronously, and the students worked on them on their own time. It seemed like it was valuable to introduce them to the students before you assign them, but we've had good success with the asynchronous part. Kyle, are you going to jump in on that?
If you don't mind, so John, I've been using this for a long time, and I'm one of the authors, but I've been using the Math You Need for quite a while, going back to the introductory stuff. And one of the things I've seen, especially in the upper division classes with these new modules for majors, is I have my students that kind of work on them together. So even when they get through the module and they go on to the assessment, the problems that they get they're continuously regenerated with new numbers. So they're working on similar problems, but not the exact same problem. So what you're asking about, if I'm reading your question correctly, is, pairing students up. But one of the things that just has organically happened with my students is they're working together on these, and the students that are having more success are helping the students that are struggling a little bit. So that's been really neat to see.
Yeah. Okay, we should wrap up. We're coming to the end here. Masa asked a question about opportunities to collaborate. So, that please email us if you're interested in talking more or using these. That's either Eric, Beth, or I. And we can, if you want to talk to an author, we can help you get in contact with them, or us, we can talk more. And then recommending any similar but higher level modules. Barbara asked this question. Yes, Barbara, we have lots of recommendations for that. And on the Matthew Neuroscience Majors Needs site, there is a list of other activities and projects that use higher level math. And we'll make sure that resource is on the webinar webpage, especially statistics, things like Project Eddie, Getsy's stuff. So we'll talk about that.
So not math skills modules, but like now they know some math and I want them to use it. That's what I just dropped in the chat, is the search that we've put together for that.
Okay, I want to move on. That was a great discussion. I'm sorry I need to cut it off, but we're almost out of time. If this is something that you are interested in really paying attention to and are thinking about going to GSA, or you've done any of this kind of work, whether it's within activities or a course or a department scale curriculum around quantitative skills, we have a session on quantitative and data skills in geoscience education that we'd be happy to have anybody that's done any of this kind of work or interested in this. So, please consider that. The abstracts will open on May 1st. So you should see that then. And we'll try to remember to send it out to this community anyways. And before we wrap up, I want to acknowledge our advisory committee. So that's Stuart Bursma, Mike Brzezinski, Kyle Frederick, and Jen Wenner. And from Earthscope, there were 2 student interns, Isabel Metz and Ann Thomas. All the students that tested this stuff. NSGT for helping with sponsorship and dissemination. And then the NSF stuff is on the bottom right there. That's it. So I'll just move to the last slide and move it back to Ashley.
Great. Thank you so much, Rory, Beth, and Eric. That was a really wonderful webinar today. And I'm really happy that everyone was able to join us. I want to let you know that since we have been recording the session, we will be submitting it to be captioned, and that will then be posted on the website, and I will send out an email to all of the registrations and the NAGT webinar list so that you can all have access to that. If you would like to have a certificate of attendance, and you can complete the evaluation, which I will send a link to in the chat here in a moment. Just to be clear, this is not a certificate in terms of like continuing education credits. It's just an email that indicates that you had attended. I'll send that now. Great. Otherwise, our next webinar is on April 30th. It's geochemical databases as an entry point to working with big data. You can go ahead and register for that. We'd love to have you there. Thank you, everyone.